Hi, I'm going to give you a little bit of an R primer, if you will, to get you kind of up to speed on using R if you haven't used it before. I guess the first thing you got to do is download R. So you go to rproject.com, go over to here, uh, find your mirror site, just download it from the cloud, accept all the, I guess, standard options, defaults, and then go to R Studio, download the free thing. And if you want to learn a little bit more about R, there's this site called swirlstats.com. I'll be looking at this and have some comments on the class for the next day. All right, so we've downloaded all the R components into R Studio. And then what else can we do? We can go over to R, click that on, bam. All right, R, do your magic. And here we are. We have this first thing that pops up. All right, so you just click on this thing. Whoops, that's too much. All right, so right here we have, up here we have a script console where we're going to do some coding and we can write out code, then execute it later. Down here is a console, I guess the console right there, where it actually, R Studio interacts with the R program, and this is where the output and executions come. Over here, we have a place where plots get put in, executed, and we have packages that we can download. And up here, we have environments that'll tell you what kind of variables we have. Okay, so we're gonna put some code up into the code section, the script section, and I've already provided some code called R, Intro to R, something like that. It's on the Google Drive and up on the Blackboard in PDF form. So I am going to, well, before I do that, I'm going to go to Session and set the working directory to where I have all my data. So I'm going to choose a directory, and I have all my stuff on the Google Drive and this course, Lecture 1. So I'm going to set that as my backup, or sorry, my working directory. And so if I save anything, it'll be saved there. All right, so I can go down to this, and I have a file. And here's Lecture 1 R and R. It's a R file. And what we see is a whole bunch of stuff here that I'm going to go over in the next half hour or so. Get rid of that. And I'm going to make this a little bit smaller. All right, so what I'm going to do is, first of all, I'm going to talk about lists and this structure function. And down here, I have all this stuff that I'm tired of looking at. If I ever want to clear, I can go Control L, and it clears it. I'll make some room over here. All right, so let's get started. All right, first of all, I'm going to assign some values to variables. So this less than sign dash, it says 3 will be assigned to W. A collection of numbers will be assigned to X. And if you put an L after an integer 3 will be assigned to Y. So this number up here is just a number, but I'm making 3L an integer. And I guess also have a character. All right, so I can, the ampersand is a comment. So I can highlight all these and hit run. We see down in the console, something happened here. So what I'm going to do is go down to this line, and these semicolons will execute this as if it were 4 lines simultaneously. So I execute that, and I see I get my 3 for my X. My collection, I guess that's what the C stands for up here, collect or concatenate. X is going to be an array of 3 numbers. Y, do we know if it's an integer? I don't know, but we see that Z is going to be a character. All right, so let's take a look at what this ls function does. Ls with nothing in it. Whoops, I didn't want to do that. I just go Control Enter to execute this line. And so what the list says, it will list all the objects that were created. So I've created these 4 variables, and a question mark will give you the help file. So help file on the structure, it lists you what kind of structure we got here. You can read it up on your own. But let's take a look at some of these things. I'm going to highlight all this junk. And so what we see down here is that if we go structure 1 or W, it tells us we have a number that was W is a number and it's 3. The X is a 3 width array of numbers 10, 20, and 30, and Y is an integer right here, and it's a 3, and Z is a character. Control L to get rid of this junk down here. All right, so one thing we can do is talk about a list. A list is just kind of a collection of objects, and they don't have to be the same. They can be integers and characters. They don't have to be the same size, but I'm going to call it a dot list. You can have names with dots, and so I'm just calling this list a dot list. And so what I'm going to do here is I'm going to create the list, hit it, Control Enter, and this will print it out. So the list contains 3 items. It's going to be the W, the X, the Y, and the Z. And if I look at what the structure of the list is, it shows that the list is going to be made up of a number 3, a collection of numbers, a 10, 20, and 30, an integer 3, and a character pool stats. So the structure can help you tell what kind of objects are within a list. All right, so one thing I'm going to do, I'm going to create a list. Instead of just calling it list, I'm going to create a labeled list. So I'm going to call this variable, or this list really, a.list.labeled. And I'm going to say it's list, create, and John is going to be the name of my first item, first object in a list. So I will give it the W value. Paul is the name of my second object. George is my third object, and Ringo is my fourth object. So I will assign these parts of the list W, X, Y, and Z. So I do that, cool. And now when I look at the string, or sorry, the structure, what I see is that the first object is called John, and it's the number 3, Paul, George, and Ringo. All right, so the cool thing about this, do the Control L. Let's see. The cool thing about this is I can back out items from this list a few ways. I guess I have 3 ways to back out. So first of all, I can do a list with its brackets 1, 2, 3, or 4. So this tells us which item will get taken out of the list or returned from the list. The first, the number 3, the second collection of numbers, the third integer, and the fourth character. So we hit all these things, and we see we get the numbers back, and the parts of the list, the sections of the list are called John, Paul, George, and Ringo. Another way to do it is to look at your A list labeled, and with the square brackets, type in with quotes the particular name of the item. So if we go A list George, A list labeled George, it'll give me my integer. So if I do all these, right, so it returns all the items in the list. So lists are pretty interesting. All right, so look at the structure. Yeah, we got that. All right, so one thing we have over here is we got parts of the list that are labeled John, Paul, George, and Ringo. So we can also pull out things without using the square brackets, but by putting a list, the name of the list, followed by a $ John or a $ George, $ name of the item. Right. So if we do that, hey, we get the same information. Oh man, let me highlight all this stuff. All right, so we get the same information. For in the first row, we get number 3 and a collection of numbers. In the second row, we get the integer 3 and the cool stats. So that's, and if we look at the structure of a list $ Ringo, it is that character. All right, so now we're going to have fun with arrays and matrices. All right, so I'm going to create an array 15 units long by this R norm, creates standard normal variables, 15 of them, and times 100. So it's just randomly generated numbers. So this B is going to have 15 numbers in it, and I'm going to create some variable C. And this kind of makes sense. We have a collection of ones repeated 5 times, a collection of -2s repeated 5 times, and 3s repeated 5 times. And so here's my 15 numbers right there. All right, so what I'm going to do now is put B and C, these arrays with 15 numbers in them, into make a column vector out of it. So this cbind function will combine B and C in terms of columns. So B will be column 1, C will be column 2. So it's cbind for column bind. All right, so I'm going to call this created matrix d.column.combo for combination. Do that, beep, Control Enter. It's not working. All right, go up here. Control Enter there, right? I look at it and there's my B column and my C column. Look at the structure. Yeah, what we see, it's a 15 by 2 matrix, and it has, I don't know, the names of the items are B and C. All right, so I can also create a 5 by 3 matrix over here. I'm going to call the data in C, the 1s, -2s, and 3s. I'm going to say there's going to be 5 rows, and this last item by row false. The false by row is the default. So if I hit this, what I have is 5 rows, and by default the values of the C array will be filled down the columns first. So we get the 1, 1, 1, 1 going down, the 2 going down, and the 3 going down. All right, so if I create another variable in a matrix, a 3 by 5, I want to have the data filled by the rows. So I want a row of 1s, a row of -2s, and a row of 3s. So the way to do that, we create a matrix. We're going to, with the data is going to be the numbers in array C, and we're going to have 3 rows. And so that by default, there's going to be 5 columns, and we're going to input by row. So we do that, bam, bam. Hey, there it is, it works. And so there's a structure, it's a 3 by 5. All right, so we've created these matrices, and if we go back to B, let me just put in what the B is again. So B is an array of 15 randomly generated numbers, and so we want some descriptive statistics. All right, so we have the typical mean, variance, standard deviation, and median. So we can highlight this and run them all. And so we get the information. So here's the variance, square root of the variance is the standard deviation. All right, so we have that. Right, now we're going to talk about the quantile or the percentile. And so if you want to read up on the percentile, $ quantile, and we have the help column down here. So first of all, we need to put in our data, and we're going to have probabilities, the percentiles we want. And so the cool thing about this is, we have our randomly generated normal values. That's going to be our data, and we're going to have the combination or collection of the 10th percentile value, 25th percentile value, 30th, 75th, and 90th. So we do that, and so the output, there we have it. The 10% of the values are going to be less than -93. 25% of the values are going to be less than -45, and 90% of the values are going to be less than 16.9. So I don't know, it's pretty cool. We can get multiple outputs right here. And we can do so what do we have here? This D column combo is, again, let's take a look at this again. So we have two variables, and if we take the variance of two series, what we're going to get is a covariance matrix. All right, so this gives me the covariance matrix. Here's the variance of B, here's the variance of C, and the off diagonals are the covariances. So if there were 3 columns, I'd have a 3x3 covariance matrix. You can get the same thing with covariance or cove D column combo. So same thing. And if we went to correlation coefficients, we have this. So the correlation between B and C is about 6.9%. All right, so maybe we want to have some skewness to measure the shape, and does it have fat tails? To do this, we need to input the packages E1071 and Psych. The one to do that, if you haven't installed it, you only have to install it once. I've done it before, but I'll do it again. So if we have E171, we'll go to our repository, so we download it, and once it's installed, and I have pre-installed Psych, but we go down here, let's see, E, and there it is, the E71. So what I'm going to do is I'm going to load this into I got to check that function, and so down here the library's been added, and I'm going to look at Psych. The library's been added down here. So now I can look at the skewness of B. So it's negatively skewed. The kurtosis, actually, it's not really the kurtosis they give you, it's the excess kurtosis. It's the kurtosis -3. And then there's this describe function that's part of the Psych. It gives you all the descriptive statistics. So we have the mean, the standard deviations, standard errors. And if we go over to here, let's see what we have. I guess we don't have anything, but let's try something else. Let's put the descriptive statistics into a variable. So descript B, and we're going to assign it the describe B combo. So we do that. And over here, we can see that it's part of our environment. We can click on this and we can observe, hey, that's a nice decimal points. What the mean of the two items are. Here's our, I guess it doesn't give us variance, but we have the standard deviations, the median, the skewness, which we had before, the kurtosis. So it's pretty neat stuff. All right, so we go over here. Oh man, we had fun with that, right? Who didn't have fun? I did. So let's look at this function called the apply function. And before we do that, I am going to load up or install some outside data. So I'm going to import some data. Let's see, it's an Excel file from my home directory. So browse goes to the directory, and it's going to be, where we are, returns. And I'm going to call it ret, or lowercase, import. There it is. So the returns, it's right here. We have 120 observations of 8 variables plus this first column, annoying column of observations. So let's go back to our code. All right, so the code, let's look at what the return is. So we see returns a data frame, which is a collection or a table, a collection of variables that need not be of the same type, but they have the same length. So we have 128 observations of this first variable and returns for Microsoft through the market and the risk-free rate, monthly returns. All right, so there's a couple ways we can see what's inside the variable. So we can look at head, and then we can get the first 6 values of this data frame. So the first variable is obs, 1 through 6. And if we did tail, we get the last 6. All right, so yeah, I don't want to see this first column, observations. So what I can do is I can go to take the head, 6 values of the data array, data frame array, and I only want the 2nd through 9th column. So this is what the square brackets does. And there we have the 2nd through 9th column. Another way of doing that is just to put a -1 in here, which says omit the first column. So it's probably more efficient to do it this way. All right, so we see the same output. All right, so it's Microsoft through risk-free. Right, so if we have a collection of, in parentheses, 2 and 8, what this does, it will only give you the 2nd Microsoft and the 8th market values. All right, so I got this data frame, and what I'm going to do is just create another data frame, assign everything in ret except for the first column, since I don't like that. So I do that, and now I'm going to be working with data. So I do the covariance matrix of data, and I assign it to a variable called co.mat. And so there's my 8 by 8 covariance matrix, and we can look at it right here. And there it is. So on the diagonals, it's the variances of the individual assets, and the off diagonals, it's the covariance matrix. Go back to here. Let's see. One thing we can do, we can take the means of the columns. So if we go to, you can look up what column mean is. You can take column sums and means, but not much else, right? So there's the help function there. So if we take the column means, what we get is the values of the means monthly returns for the stocks. But a better way of doing it is to use an apply function. An apply function, what we have here is a function mean. All right, so we're going to find the means of the columns of data. So this 2 right here, the second item, if it's a 2, we're going to take column means. If it's a 1, we're going to take row means. So we're going to go across. So if we take the column means, we should have 8 expected returns. But the cool thing about this, if we want, let's say, skewness, we can put skewness in instead of means, and we have the skewness of all our returns. All right, so if we look at the row means, we're going to have 120 row averages across these 8 assets. All right, so let's just say we're going to put return means into one variable and the standard deviation in another. And so that's those are the 2 series. Graphics. All right, let's see what we can do with graphics. So we can go to plot, hit enter. You can look through here. What I'm going to do, I have an XY plot. I'm going to plot the Y variable against an X variable. So this is going to be the return dot volatility is going to be on our X variable, and this tilde says we're going to have the Y against the X. But if we had a comma, we'd put the X in the first item and the Y in the second item. All right, so let's see what happens here. Let's make this a little bit bigger. Make our plots a little bit bigger. All right, so we create this. And so we have on the x-axis return volatility and return means over here. So we can zoom it out and see it, or we can export it. See, clip to copy, so you can copy and paste this onto an Excel file or a Word file. All right, so what I'm going to do now is I'm going to attach a line, best fit through the relationship. So what we see is there's a positive relationship between risk down here and average returns. So what this AB line does, it gives you a line where the first value is the intercept and the second value is the slope. And to find the slope and intercept, we use this LM function, and we'll get to that later, with returns explained by volatility. All right, so we can spruce up the chart by adding some documentation. So this main, so the thing about these functions, the plot functions, you can put a comma and use the next line, and it won't be upset. R doesn't be upset, won't be upset. So we're going to give the main title the relationship between expected return and volatility. I'm going to label the x-axis down here instead of return.vol. I'm going to call it volatility. Instead of ret means, I'm going to call the y-axis average returns. So let's see what it looks like. So cool, that's fine. And I put my line of best fit, and I'm going to say it's going to be dark red and a fatter, this LWD is line width. All right, so, oh cool. So we have that going for us. All right, so keep her moving, got to get going. All right, so frequency histogram. The histogram, we put in our data. All right, so if we look at the data, struct data. All right, so we see that the first column can be the data with a $sign, Microsoft, GE, GM. So I'm going to take a histogram of the Microsoft column of the data frame. So here's what the histogram looks like. So I can make them have more bins. So it's a little bit fancier. And the histogram, yeah, so the data in the histogram, I call hist mist. Yeah, so let's see what's comprised of this. Actually, there's a list. Hist.mist is a list. It contains the breaks. So right here, the break is at negative 30.35%, and it goes to 0.2. So the breaks, it gives you the breaks. It gives you how many items are in each of these bins. So this bin right here has 20 return items. And it gives us the density, which is the relative frequency of these items happening. Gives you the midpoint, names, and I don't know, other things. All right, so we can spruce up the chart by giving it a title, making the column a other color, and giving the X column a label. And so there it is. Is it pretty? Yeah, it's cool. QQ plots, quantile plots. I don't know if this made sense in the class, but it probably won't make sense here either. All right, so first of all, we're going to look at the eighth column, the market column, like the S&P 500. So one way to do that is go the histogram of a data $ market, or we can have these double brackets because we're in a function. So the double brackets, quote, column title will give me the histogram of the market. Whoa, and what we see is it looks like the market is negatively skewed. And if we remember, go back and look at our histograms, our descriptive statistics, we see that the market is indeed negatively skewed. There it is, negative 7.79. All right, so let's create a QQ plot where we're going to compare this distribution against the normal distribution. So we go QQ norm. So and we put in our data set. The column we want. And this is what it looks like. Oh man, so we have theoretical quantiles in terms of standard deviations, and we have returns up here. So we like to I want these both to be Z values. So to do that, we're going to scale these monthly returns into a 0 mean, 1 standard deviation values. So what this scale function does is it subtracts off the mean, divides through by the standard deviation. So if I look at this, I have the same values down here as up there, and I can create an ABA line. So the line goes through the origin, the intercept is 0, and has a slope of 1. So compared with the normal, it has more extreme downside than normal and less extreme upside than normal. Oh, so it's negatively skewed. All right, so we can spruce it up a little bit by I'm doing a couple things. I'm giving it a title. I'm making the X and Y axes the same width. It goes from -4 to +4 on the X axis, -4 to +4 on the Y axis. And this is a particular type of point. Instead of these dots right here, I want a closed dot. All right, so let's see what this looks like. All right, so that's my QQ plot. I'm going to have my ABA line. I'm going to make the color dark red. Or I don't know, let's see if I can say light blue. And with a line width of 2. So there it is, light blue. So we see this is consistent with negative skewness. Wow, moving right along. The autocorrelation function that you need to use in your homework. So it's an ACF function. You can read up on it in the help file. And so what I'm going to do is I'm going to run an autocorrelation function on Microsoft and give it a maximum lag of 10 months. I think if we left this blank, the maximum lag would be 20. Oh, there it is. The default is 20. So let's try this. Bam. All right, so what we get is this chart. And so what we see, the correlation between Microsoft's current return and Microsoft's current return is 1. But if we look at the first order autocorrelation, there's a negative correlation. And these dots right here, dashes represent like 2 standard deviation movements. So this is statistically far away from 0. But if we want the numbers, this is actually put into this Microsoft.auto, which is a list. So let's look at the structure of MSFT.auto. All right, so if we actually wanted to look at the numbers, it looks like it's in this $ ACF, and it gives you the 0 lag through the 10th lag. So let's see what that looks like. Get rid of some stuff. Right, and so those are the autocorrelations. So we have the 1, we have the negative 2.37 down here, and all the others. All right. So I can spruce that up if I want. So let's see. I want to combine the what else is, I guess I want this up here. I want to combine the lags, which is 0 through 10, a column with the lags and with the columns of the actual values. So I'm going to create a table. As table, I'm going to combine the number of lags and the ACF values. And there it is. We got lags, and man, maybe I could even put lags as integers or made them L or something, but hey, I don't care. Let's see. And there we have our autocorrelation function. All right, so one thing we can do is we can write some objects to, let's say, a CF comma separated variable file. All right, so I'm going to put this matrix and save it into a CVS file so I can pop it open in Excel. So I have write file CVS, here's my data, and this is the title I'm going to give it. So let's see what we got here. Pop. And if I go to, let's see, the Google Drive, my drive, lecture 1. I see this ACF function, it's a CVS file, pop open. And there's my values. All right, so if we go back to the R, I guess I did a couple other things here. When I combine these two columns, I said the first column I'm going to label as lags. The second column I'm going to label as ACF. And so what we see down here is the first column is called lags, the second column is ACF. So if I go, let's see, get rid of that. Sorry. And if I can type things in here too. MSFT, ACF, $, lags. Oh, it doesn't like that, huh? I forget I said anything. Did I say anything? No. I guess maybe what I want is the first column